Good afternoon, everybody. We are ready to start the call. The topic is AI in service, examples and lessons learned. And today I have as a guest Johannes Perensen from GMS Development. A bit of background. What we are going to talk about is a bit of background is the Service Business Forum. What it is? It's a community for service leaders and executives of several manufacturing firms, and that want to be inspired and challenged and equipped to capitalize the full potential of the service business. And we have been organizing events based on research. And what we have done in June this year in Zurich is we had an event which was talking about the use of AI in service. That event was basically attended by approximately 30 people, and all executives in service, and we covered approximately the research covered like 100 different case studies, and you can read the conclusions of our discussions and the research in the report that you can find on the website servicebusinessforum.com. However, the question that we got from many of the participants is, can you show us some examples, some practical examples? So that's what we're doing today. As you see, we will have other forum sessions. Actually, this week in Vienna on the 28th and 29th, we will be there talking about service business drives profits. Then on the 23rd and 24th of November, we will be in Stuttgart talking about all the potential of the industrial metaverse in service. And in March next year, 7 and 8, we are back in Zurich talking about engaging people in a world of shortages, basically talking about the increasing skill shortages and how to deal with that as service organizations. What you will hear today is from GMS Development, so that's from Johannes. Maybe Johannes, you want to take a moment to introduce your company to the audience?
Yeah, thanks a lot, Hilbrand. So I'm from GMS Development. So who are we? We're a company from Germany, in sort of the middle of nowhere, in a place called Paderborn. Which is an IT hub in Germany. Our company was founded in 1987, and for the last 23 years, we've actually focused on field service management, or what is now called field service management. That means it's the automation of field service processes, with a focus especially on companies who have many engineers, and those many engineers have a lot of jobs per day. So automating, scheduling, easy to use software for the engineer, etc. That's been our focus, where sort of all of our 80 employees are geared towards. So my personal focus is I used to run a service organization myself. So if you want to ask me a question about software development, I'll very soon reach my boundaries. But I'm sort of here to explain use cases, business cases, and understand yours.
All right.
Thanks a lot.
Thank you, Johannes. Giving you guys a little bit of background on what we discussed during our Service Business Forum, and that was basically part of the part of the research. So we discussed all kinds of let's say applications, business applications, and I'm showing you two levels of what we discussed, like the so-called reactive field service process and so-called preventive field service process. And of course, we discussed all these different possible applications, but we limited our discussions to a number of examples of what you can do, or we will limit it today. And here you see the 5 examples that we will cover. And so the first one that Johannes will talk about is how can you use AI in the so-called triage process of contact center. So when the service request or ticket or case of a company comes in, of a customer comes in, how to help use AI to have that more effective and let's say productive. Then as soon as you are able to look at what it really is, what the job is about, AI can be used to create a forecast of how long the job will last. Obviously, that can be used in automated scheduling and the process itself. In automated scheduling, there is several uses of AI, and the AI can help to recommend the right spare part to make sure that the field engineer has the right parts in the van. And then when the field engineer is on the job, obviously we all want the first time fix, and their AI can also provide, let's say, some help. Now, obviously, we realize this is only a couple of examples. Please read our report. You will see numerous examples of how AI can be used. And I think one of the conclusions was that it's going to quite dramatically change the field service business. Now, we also did some investigation. When I say we used the Noventum benchmark database to look at the potential of these particular improvement opportunities. And we did that by looking at our benchmark data on how the field service organizations and support center organizations, how do they typically spend their time? And what you see here is a chart of the average time spent. You have to imagine this is a database with hundreds of companies. So this is an average of several hundreds of companies where we show how time is spent. And obviously, what you see here, if you divide up the colors, you see that quite a lot of time is spent on so-called low-value activities. These are activities where if you ask the customer, they are not willing to pay for it. Yeah. So this is administrative or other inefficient work that you either have to reduce or eliminate. And we think AI can be of great help there, on top of the normal digitalization efforts, of course, because that doesn't deliver all the productivity improvements. Now, AI can also help in the so-called value-added activities that you see here in blue. And it can also help in, let's say, let's say medium level activities. Now, if you look at just the amount of low value activities, 44% on average, what they spend in a support center and back office, that is a huge potential, of course. So that's where I think we can have an interesting discussion about, and Johannes will give some 4 examples on how to reduce that time. Then if you look at the field service delivery process, it's a bit of a similar story, but you see a lot of low value activities there typically. And a lot of that has to do with what we may call knowledge management. So you see a lot of activities of field engineers that have to call all kinds of people, technical support, customers, others, their colleagues, let's say the office, the support center, And besides that, they are spending also a lot of time on activities that also should be or could be reduced. And of course, if you have a better, let's say, knowledge management function, you could potentially also reduce some of these activities that we call high value. So repair activities can be more effective, installation, all of these activities, preventive maintenance can be more effective, and you can do more with perhaps the same number of people. Also, you will see here the travel time. Obviously, that we're also going to discuss that. So on average, it's 13.7%. That's also some potential in there. So this is what we see as the biggest areas of potential that we will discuss today. Now, of course, there's many different business cases that you can make from this, but today we look at really the potential productivity improvements that you can achieve with AI. So Johannes, you are going to give us some of these practical examples, and I believe you can even share like some demo screens on how that really works. I'm gonna switch the screen over to you.
Yeah, I've taken over the screen. Thanks, everyone. You should see it now. So just again on what I'll show you from a demo perspective. I'll show you how we do guided triage. That means how we're going to help the especially contact centers. How can we recommend spare parts to a job, and how can we suggest or forecast how long such a job will take? Because this is the difficulty that we see with our customers at the moment. The move is always towards outsourcing more and more activities to contact centers, but contact centers are not technically skilled. So how do I get the technical skills to be still effective in the service? And this is just a showcase on our demo environment, which I'll share with you. Yeah. So this is our software. This is the UI which we typically provide to contact center staff. Each of these boxes or tiles, as we call them, they can be assorted as they like, and it is still dependent on. This is more or less dependent on what the customer would like to cover in taking an order. So what I'm simulating now is, as a customer on the phone, Mr. Friedrich, I'll search for him or her. We find an account because it's a known customer. There's as well a way to log new customers. It's a bit dependent on the industry. The customer has a location, and at that location he's got a range of equipments. In that case, I'll use Mobster, which is a washing machine. So the customer is still on the phone. I can check his contact details. I can check whether the data he's providing me is correct. I do see that he doesn't have any contracts, so there's no service contracts in place. Otherwise, I would see the terms and the conditions of the service contracts. But I do see there's a huge number of historic service orders. I can. Obviously, this is in a demo environment. This is my most favorite customer. I can explain. I can even dig into what the customer has done in the past, or what the engineer has done in the past. This is just for information, and I'll realize, okay, I've got the right customer, the right device. I'll create an order. So the order is created. Probably a bit longer because I'm waking up my demo environment today. This is normal description. I can still define on what type of survey activity is, the priorities required if it's not sort of provided by the contract, and then I'm creating the service order, meaning every phone call of a customer is captured as a service order in this case. I have here the details of a service order, but I want to direct your attention towards this assessment dialog. this is the guided triage, because in our experience, we very often have the case that the field experience says that customers should have solved the issue on their own. With if they had sort of technical support, they could have solved it on the phone. The other alternative is the engineer always has questions when he's preparing to site, because he needs, or a technical support has questions in order to further narrow down the extra spare parts that are required. Yeah? So that's why for this, we can, in this case, this is a guided dialogue. Those guided dialogues are typically provided by technical support to a contact center for those always reoccurring issues where more questions should have been answered or more support should have been provided. So this is still no AI. I'll share with you in a second where the AI comes in. Yeah. So what error message it is, and depending on the error message, it'll ask him a couple of further questions, and if he still can't solve the issue, then we're getting to a point where we actually have the assessment result. And this is just for demo purposes that we show it that often. For if it depends a bit on the user. If the user is non-technical, then he's probably not interested in it. If the user is a kind of technical second level or technical support, then he might want to validate it. Basically, it shows that for repair of a mobster, and the error message on the device is an F10. There's a 70% probability that it's an on-site repair is required, and this is suggested as spare parts. Yeah, so there's a cable, a fuse, and a filter with these probabilities, and it's suggesting as well how long such a fix would take. I'll explain with lessons learned a bit later on how we can get to this feature. And this is AI, but it's a lot of statistics as well. So it's a bit of both. It really depends on the customer situation, the quality of the data, etc. Yeah, but I'll share the details when we talk in terms of what AI technologies are used then on the later slide. Yeah. This is just a use case. Hilbrand?
Yeah, just so this is, if I understand, this is for a standard product, right?
Exactly.
And what if you are a service organization where you have non-standard products? Will AI be able to help you in the same way, or would that make it very different?
I think it depends a little bit on how is then the spare part defined. So if the spare part cannot be defined by the product number, then the question is it by the product group, or is it by sort of the bill of material that comes with the device when it's sold? This is something that needs to be looked into detail, to be honest. Yeah, because if the product with always the same name can have multiple different configurations and spare parts, and this needs to be looked up, and most likely the bill of material is to be reviewed for that particular product in the suggestion. Yeah. But to my experience, it always depends on the quality of the data and the available data in the companies.
So if you have standard products with clear error codes, then teaching AI what to do would be easier and faster.
Yeah.
But if you have non-standard products, it becomes more of a statistical chance calculation of this could be the case or that could be the case.
Yeah, or potentially there needs to be lookup to the bill of material as it was produced, or there can be like fallbacks, meaning for that product that there's always this I don't know, the screen needed, and the lookup for the screen is where do I get the information which screen is required? Is it the product group, or is it the bill of material? This can be automated, but the data quality needs to be quite good.
Yeah. So what the benefit of AI in this use case is that obviously the I would say the experience of the customer is more positive. It goes probably a lot faster, as if you have to go through more extensive dialogues on the phone or email exchanges or chat. But also the time that the person spends, the support person spends, is probably significantly less. Have you, what's your experience? Can you mention any whatever saving in time to have this AI use case here?
There's multiple angles in terms of savings. Yeah. So the first one is that obviously we want to save the second and the third call. So the customer gets he's get a fully vetted call or a service order with the first call, and he already gets an engineer appointment, which I'll show in a second. So this saves further interaction with technical support, with dispatch, etc. So their savings are per call from, I don't know, probably 10 to 20 minutes that you save on each service order. At least this is the benchmark of those industries that I've been working with. Obviously, the second benefit is then for the engineer and the documentation, because he will already have his spare parts ordered for him. He can have he can document the spare parts easier, and but then sort of if this system is working fully, then you have additional benefits in terms of first time fix, in terms of changing the spare part model from an on-van stock to ordered to service order. So just in time delivery of spare parts. So there's a wide range of benefits. But obviously, for this needs to be trialed first, proven the reliability, and only then the changes and then the benefits will come in. Yeah. But the easiest is it's just saving time.
Yeah. And what's your experience for these use cases here that you mentioned? How long would it take before you have an acceptable level of reliability?
Let's discuss it. Let's discuss it when we talk about the sort of the lessons learned, because I have exactly for that one I have a lessons learned
Okay.
that I can share, and then that's I think that makes it that they will put it into a better context. Yeah. So just continuing, I've sort of completed the technical clarification. I know which spare parts I need, and hopefully I haven't run into a timeout now, because I can just add those spare parts to the job, which you see here under parts and services. Under parts and services, there should be the UI coming up, and if I click for proposal, I do see the spare parts. They're all suggested, even with prices, etc. If I see, well, saying that I don't need the filter, I can just delete it. Yeah. We have this process in other customers. We've done this fully sort of under the hood. That means if there's no technical person involved, we would just add the spare part recommendations without sort of the person taking the service order, notifying it. Yeah. The other benefit obviously is the person still, the customer is still on the phone, and I do see here the service order takes 45 minutes, and I can check. I can request proposals. That means what our software is doing is checking the planning board and the scheduling for available engineers, and it's offering time slots. This is a very basic way of offering time slots. So each box is a time slot. We offer typically we offer a range, a time range, so that if another job comes in nearby, we can shift it a little bit. But with this, we can, if the customer doesn't like it, we can still change it. Yeah, we could take it. If the customer says, well, it has to be in the morning, then it's going to be the first client, the last client, etc. So this can be fully refined. Likewise, with the service level, we can order as well additional engineers. So all the stuff that the dispatcher would do for standard calls, we shifted to the call acceptance, basically. Yeah. And if I click on it, it would then book it would book the service order straight against the engineer. Here you just see hidden that the acronym of the engineer, but we can as well show the name, or we can as well show the where he is on the job before, how long he needs to drive, etc. Behind that is sort of the planning board, as you've seen. Yeah? So we know for each engineer, we know his qualifications, we know the where he's based. We have the time, his working times exact here, even standby, etc. And compare it against the service order, and then make suggestions. Yeah? A dispatcher can do basically the same. So if he's got his work queue of, say, maintenance jobs to do or escalations, he can just pick one, and he's doing the same. He's clicking on get appointments, and here again he's given suggestions. Yeah, this is for semi-automatic dispatch. It can be done. Maintenance orders typically we just dispatch automatically because they're not time critical. This is for a bit more time, for a bit more time critical. We have sort of kind of assisted scheduling. Yeah, I'll share with you the sort of the lessons learned from automatic scheduling and how that relates to AI in a while afterwards, when I've got a couple of slides. But this just for the use case, so you understand where we are. We've fully vetted and diagnosed the issue. It's now scheduled to the engineer, and the engineer has this app. It'll look like this on a laptop or tablet, and a bit like that on the smartphone. So it's responsive design, but so far this is not AI. I'll just let me just pick up my non-completed jobs, which is this one here again. I have the mobster. It's a normal app. I don't have the time to go into detail to that. What I wanted to point out is basically, if he's on site, he knows what to do, what he's expected to do, but he needs support. He needs help to solve the issue. He can then get to this device button, and we would just integrate. We have an integrated knowledge management, and the knowledge management is already filtering the documentation for this product. If I want to widen the search, I just click away the chip here, and I can do text search as well, and it's showing me all of the documents with the text related to that. So here again, how is this AI? I mean, knowledge management has been around for quite a while, but knowledge management is getting even better and better. We're working here with a partner, so we do the integration for service companies, and the actual sort of technology beyond or of the knowledge management is provided by our partner, but they have from large language models to knowledge graphs to semantic search. That means it's looking for similar expressions. This is all sort of injected in knowledge management, and is making it more and more effective for the user. Yeah. And I think that was it in terms of the demo. I would just share a couple of lessons learned. That's okay for you, Hilbrand?
Yep, go ahead.
Yeah. So I'm sharing one use case that we had for spare part recommendation. That was actually the first one. Some time ago, and you see here sort of the expectations was there's a customer, he or she is providing a couple of error codes, or might even say, well, my water is not getting warm, and then the desired result is spare part numbers which can be attached to the service order. The basic, and just for this sort of the basic savings expectations is 5 minutes. This is for a technical person to look up the spare part numbers, and obviously, the better the quality of the spare part numbers, or the better the quality of the predictions, the less number of revisits there are. So that was the expectation. And what do we do with that? So how is this AI? The first one is, if you're in a multilingual call center, the first one is the AI model needs to detect what language are we actually talking about. Is it English, French, German? And as well, we have a couple of countries with multiple languages, obviously. Then we've trained the AI on word patterns. That means which words are quite similar, just different customer expressions. We have a neural network which, for instance, says that that words are not so important, but if you get error messages, then they have a high importance. And based on that, there's deep learning algorithms who then suggest require spare parts. The suggestions, then we learn this is then sort of when AI is hitting the business, that you can't always suggest any spare part. For instance, if they're too expensive, then they shouldn't be suggested because there is separate processes for that. And some of the spare parts which were used in the past shouldn't be used anymore in the future. So we need to identify replacement parts. Yeah, so all of these steps we have gone through to provide to then automate the process of recommending spare parts. And the most interesting thing for me was that actually we were fully trained. The AI model was fully trained. Everything was up and running. And by the time we piloted, it was actually COVID starting. So strange words like you can see here, COVID-19, suddenly entered the error description. And this is nothing an AI model can work with, because it was trained in the pre-COVID world. And this leads a bit to sort of the conclusions that we had, I think 2 years ago, which leads to more different a process for that. So we don't do this black box approach anymore, because we've realized that it's actually if you have error codes or symptom codes, if they are captured, then they provide a lot better results than text descriptions, because text descriptions, they can change. Another customer, he after the training, he outsourced the contact center, so you get totally different text descriptions than you got before. And for fully AI model, like I've shown you, we actually need, to my experience, we would need product. That means that they're fully standardized. We need to fully deploy this. We need training material, and even although for our customers or long-standing customers, we have many years of training data. If you have a product which is only deployed once or twice in a country, or let's say 10, 15 times, and doesn't really have a lot of service orders, then this takes a while then you don't really have enough training data.
So how do you define enough training data? Like, is there just you look at the statistical relevance, like the whatever standard deviation or something?
So what we do when we train, we typically have we take the data, and we use 80% for training and then 20% for testing, because you can't sort of test the AI on the same data as you've trained it on, because then you get only the expected results. Yeah. And after testing and during testing, we're using a kind of a confidence level. That means for each suggestion we get a confidence level, and that reflects as well that reflects sort of the data quality that we had during training. Yeah.
Okay. Yeah. And I don't know, can you give an idea of, for example, how many standard products and what is the total size of their spare parts catalog of an example that you gave?
Well, in the example that I've just highlighted, I think there were 4,000 different products installed in one country only. And then obviously the products then have, I'd say it's at least a 6-digit number in terms of spare parts.
Yeah. Okay.
Yeah.
All right. These are interesting numbers.
Yeah.
Thanks.
Welcome. So the other takeaway, obviously, for success criteria is the business process will be different. And you can see it in the case of spare part recommendation. What do you do with the recommendation? Do you want the spare part to be ordered to the engineer? Do you want the engineer to check the spare part recommendation first? Do you want to schedule an engineer who has the spare part in your boot? All of this is to be considered, and the business process needs to be redesigned. When we started it, we were actually trying to get the same to keep the same business process, just add spare parts, but that didn't work. And last but not least, obviously, we need to when you pilot it, you need a pretty good feedback loop. That means if the spare part recommendation wasn't correct, why was it the case? What is the learning? How do we mitigate this happening in the future and change it? So it's a project on its own, and it needs a key user for that. Yeah.
You get that back straight from the field engineers.
Yeah, exactly. Yeah, we can, because if we, as I showed, if we're adding the spare parts as a recommendation, and if the engineer is not using one of these recommendations, or if he's not using any of the recommendations, then we need to do a root cause analysis. Yeah. Okay. But that's what you typically do in a pilot, obviously, until you get to a level of confidence, so that you can roll it out, and then you do the analysis only on a monthly basis. Yeah. I have one more example of automatic scheduling, and so there again, take a black box. You have a service order. You want to have it scheduled, and what you want is you want to have an appointment for the engineer on site, and you want to have optimized tours or routes for the engineer. Typically, we can save the 15 minutes in the dispatcher typically takes, and from our experience, we can save as well the drive time of an engineer, because he's driving optimized routes. The black box sounds quite easy, but I'll show you a little bit of the details that sits within the black box that you will need, and this basically shows all of the data that is required in order to automate. Obviously, a service order needs to have a pretty clear customer data, the address, the available time windows. First issue is how do you know the duration of a service order? The second issue is how do you define from the service order which skills are required, and which if there's specific tools required or specific parts. This is data that needs to be on the service order. I mean, we showed previously how we can help this with AI. But obviously, this is data that needs to be available for automatic scheduling as an input. The next challenge is then we sort of do a hard triage. I would say, is like, do we have engineers who are nearby, who have the qualification, who are actually working, and then who have the skills and who have the tools? This is sort of you get a list of engineers who might be able to tend the service order. We're checking the availability of parts against the service level, so that if you get finally you end up with 5 to 10 engineers, and then starts the optimization. Because what is the optimal engineer? Is it the one who can be there the fastest? Is it the one who can be there, who's driving the least, who's creating least cost, or is it the one who doesn't have anything to do? So we need to get him productive. This is sort of the criteria that's taken place there, and this is an optimization that's taken place. And the question, I think the question that actually came up is like, is scheduling AI, automatic scheduling AI, and sort of one of the examples that we're typically facing with customers is there's a maintenance that needs to be scheduled in 2 months' time. There's actually additional jobs for the same machine or for the same site, so they are bundled. And then for the bundling, there's rules. So if there's 2 jobs at the same site, is the travel time just added, or can they be done in parallel? And if what happens if the total working time is exceeding the time of a day? Is the person staying overnight or not? Yeah, so this is sort of typical examples that we see, and you could argue that it's machine learning, but it actually isn't. This is so far, scheduling has so many business specific rules, as you can see with this example, that it's actually not machine learning, because machine learning would mean that the software would make decisions on its own. Our scheduling has lots of algorithms, which means at the end of the day you can always prove why it has made such a decision, because in the use cases that we have, with our customers, we always had to prove why this engineer was suggested, and why we grouped additional jobs, and why we specify the working time not as 3 times 1 day, but 1 day in total. Yeah? So there's lots of business rules. Why so far there's no the key scheduling is not is actually not an AI in the sort of the literate sense. And I've included it because I think scheduling was one of the most named example of during the workshops in Zurich, where companies wanted to to invest in AI. It's got lots of algorithms, a lot of rules, but it's in a strict sense, it's not AI.
It's actually what you've shown us before, these use cases of AI. It's more before you get to the scheduling part, the triage, the diagnosis, the work preparation, recommending spare parts, estimating duration. That would normally be work preparation done by somebody in a support center, and that goes into the scheduling, let's say.
Exactly.
So that's where the AI comes in.
Exactly, because the scheduling is so sensitive. So the outcome of the scheduling is so sensitive that so far in our customer environments it's loads of algorithms, but they're always this is always based on very transparent business rules. Yeah.
Right. Okay.
Right. But the lessons learned are always the same. Yeah, the lessons learned that we have. I mean, be it algorithms or AI, the lessons learned or success factors for introducing it are always the same. Yeah. I'll just skip one slide, just in terms of success criteria. And because those apply to AI, introducing AI as well. Yeah, if you want to automate something, you need to standardize it first. In this case of scheduling, to my experience, a scheduler the scheduler to some extent does something different. But the process needs to be standardized before you automate it. The second is, and this is very important, is it's actually culture change, and because it's no longer a personal decision, but it's a scheduling is sort of suggesting or telling why an engineer should go there. So the dispatcher as well as the engineer need to accept that. Today, even in a non-automated way, I do see a lot of engineers discussing with the dispatcher why they should go there. And in the future, there's the authority is changed to a software. So dispatchers and engineers need to accept that software is planning their tours. And we have the data topic. Especially we have customers in sort of medical equipments where you can only send trained engineers to fix or to attend a site. That means you need to have the qualifications very accurate. Otherwise, you can't automate which engineer you want to send.
Right.
And so last but not least, it's use cases. Yeah? So which do you have many days, many jobs a day? Do you have many engineers attending one site? Do you have an engineer going somewhere for a week? This is totally different use cases that need to be, before you automate it, you need to be clear about those use cases. Yeah.
Right. So just to the audience, if you have a question to Johannes, or maybe to me about the outcome of the Service Business Forum, feel free to ask. You can do so if you look at the Q&A button on your screen. You can ask a question there. What I will do is I'll take a quick moment to share with you what are we going to do the next time on the Service Business Forum, and pointing out to you that the report AI in Service, there's an executive summary that we made of the research, including all the sort of validated findings and the outcome of the discussions, the key ones that we had in the Zurich session. You can read that in the report. Obviously, it doesn't have all the details, but it gives you a bit of a view. So you can download that in servicebusinessforum.com. And for those that live in Vienna, maybe there's still a few seats left for the session that we have Thursday and Friday, 28, 29 September. It's called Service Drives Profits. We are going to talk there about all the different, let's say, growth strategies and obviously profitable growth strategies that you nowadays find, and what would be the different strategies to go from one to the next level. And we will have some guests with some, let's say, experienced experts that will share their experience with the forum members. So you can have a look at that. And then let's see if there is, in the meantime, if there is a question for Johannes, which I think, Johannes, you have been very clear in your explanations, because there appear to be no questions.
Hope that's the reason.
Yeah. So I have a question for you, though. If you look at those AI initiatives, the AI results particularly, what have you seen so far? What is the most interesting benefit that you have come across that your customers have been talking to you about?
I think the biggest reason why there's two main reasons why our customers are using AI. The first one is the skills shortage. Yeah, so you find even less and less engineers, and then you need to find engineers who are willing to work in an office for technical screening, etc. So you need less people, but these people need to be able sort of to train and sort of enable the AI. Because there's no black box AI where you just deploy the software and it's working. You need to have people who know the software, who are keen on using the software to automate and simplify processes. So the skills shortage is one, and the second, I think, is with AI you can bring the knowledge to the consumers or to the end customers. Because they're expecting 24/7, and you don't have call centers equipped 24/7. They are no longer probably expecting to always chat or talk to an individual. Because all of them, they have already tested ChatGPT, so they don't mind if you're using a bot or large language models to talk to them. And I think this is where we do see the benefits. Yeah.
Okay. I have, in the meantime, a question for you, Johannes. Question is, can you please elaborate more on how do you teach AI?
Yeah. This is a bit. The first question is, what do we want AI to do? And do we want AI to detect patterns and find out a symptom code, and you then afterwards you have enough statistical data to specify the spare parts required for a particular symptom code? Then it's a different sort of exercise than you take just a language description of a problem and you won't have a spare part coming out of it. So it's a bit, the difference is the quality of the data, the training of what data is available, what do you want to achieve. It's a bit dependent on that. But at the end of the day, importance is we're training with historic data, and the historic data is then will then define models and define the actual AI model that is then used for operations. And how much data do I need? It's a difficult one. It really depends on the example of the customer that I gave with 4,000 different products, with installations of 1 to 10,000 in the country. You need as much data as you can get. If it's one product, or two products with loads of service orders, then you need less.
Yeah. Right. Okay. All right. Well, I think we don't have any further questions, so thank you very much, Johannes. I would like to thank you a lot. I think this is a very good example, a very practical example, and one of my observations is that you don't need to be a super sophisticated service organization to start using AI. Yeah, so what you are showing are very practical examples, and I'd say most people that have, or most service organizations that have a bit of a decent, let's say, service management application, they can probably see already direct possibilities to use AI. And if you look back at the slides that I showed in the beginning, the improvement potential only in productivity is already good enough. So it means that it would very quickly pay it back for itself, let's say. And then all the other benefits, like you are reducing or addressing the skill shortage, you are improving the customer experience, you are doing things more effectively. So yeah, obviously that all contributes to an interesting business case. And the wide variety that we have also seen during the Service Business Forum in Zurich, the enormous number of applications of AI in the service organization is just it's almost mind-boggling. So I'm sure we'll have more of these sessions with practical examples. So having said that, thanks a lot, Johannes, for these examples. And I hope that the audience found it very useful. And don't forget to download the AI in Service report, and then see you next time. Thank you very much.
Thanks for having me. Pleasure.